So here's another equation where we have to solve for a specific variable. This time we're solving for x, and we've got two x's in this problem, and we've also got two variables that aren't x's in this problem. So what this means is that we're going to have x equals as our answer, and then the other side of the equals is going to have both a y and a z on the other side. So this one's going to look pretty weird when we're finished with it. I'm going to start by rewriting the problem here. I'm going to write it real big. Here's our problem. And what should our first goal be? Well, I think there's a lot of different things we could do first. We could get the 2y moved to the right side. We could get the 5 moved to the left side. But in general, our goal when we have the variable that we want to solve for on both sides of the equal sign, like we do here, is to get them on the same side. And so I want to stick with that as our strategy, get them on the same side. I'm going to subtract xz on both sides. Now I can't subtract just x because that z is being multiplied by the x. So the z is attached. The z is attached to the x. It's got to come along for the ride. So it's not ideal that I'm bringing a variable along with me, but it is what it is. And I cannot combine the 3x and the xz because they aren't like terms. One is just a plain old x, and one of them is an xz. Now the xz minus xz is going to cancel, obviously, and leave me with just a plain old 5 on the other side. Okay, so that was the subtraction property of equality, and I have solved one of my big problems, which is having the x that I'm trying to solve for on opposite sides. So now I've got that taken care of. Unfortunately, I do have a little bit of a problem, which is that I've got a z and a minus 2y over here that I need to get rid of at some point. That z is being multiplied, and we like to save the multiplication for the end. So let's take the low-hanging fruit here. Let's add 2y on both sides just to get that y kicked out over to the other side. That seems like a good idea. So this is the addition property of equality that we're doing, adding 2y to both sides. Okay, so on the left side, we're going to have 3x minus xz equals, now this minus 2y plus 2y is going to cancel, right? That's 0. And on the right side, we cannot combine the 5 and the plus 2y. Those are not like terms, so we got to leave those separate. There we go. And now here's where we run into a problem. I've got the x's on the same side, but one of those x's has a z attached to it, and I want to get the z removed. So how can I pull just the z out without also removing the x? And you might think, okay, we'll just divide by z. If I divide by z, that'll work, but I'll create a problem for myself if I divide by z because I can't divide just this by z. I would have to also divide this by z, and that means these z's would cancel, but now I would have a z in this term. So dividing by z would not help me get rid of the z. It would just move a z into the denominator. So instead, we're going to do something that is a little bit tricky. We're going to use the distributive property. Now you may think, what? The distributive property? The distributive property, isn't that just when you have something outside a set of parentheses? Yes, it is, but we're going to go the opposite direction. We're going to put something outside some parentheses. See how these terms both have an x in there? I'm going to put an x outside a set of parentheses. Now let's ask ourselves a question. What would go inside the parentheses that would give me this 3x minus xz? And the answer is 3 minus z. Now let's stop and look at that for a second. Let's do the distributive property. X times 3 would give me 3x, and x times z would give me xz. So I'd have 3x minus xz. So this is the distributive property, but going the other direction. Instead of multiplying the thing outside the parentheses by the stuff inside the parentheses, I'm doing the opposite. Pretty slick, huh? The distributive property can go forwards or backwards. Now, believe it or not, we are one step away from the answer, and this step is also pretty cool. because the distributor property is multiplication. So what's going on right here, right in between these two, is multiplication. This is x times 3 minus z. So we're going to do some division here. We're going to divide both sides by 3 minus z. That's going to cause 3 minus z divided by 3 minus z to cancel. 3 minus z divided by 3 minus z is 1, leaving us with just x, which is what we wanted. And over here, 5 plus 2y over 3 minus z, using the division property of equality. And that is a pretty weird looking answer, I'm not going to lie. That's an unusual answer. But we got x all by itself. X equals, and what it equals is a nightmare. What it equals is definitely ugly, but we don't care what the right side looks like. We care what the left side looks like. The left side is x all by itself, and that's what the problem told us to do, solve for x.